Hi class, how are you today? That's either great, terrible, or somewhere in between. Alright, the learning target for today is to identify the type of system of equations and how many solutions it has. So, we've actually only been dealing with one type of system of equations at the moment, but there are other types. And some people I know already have sort of discovered that there might be another type, but may not have noticed it yet. Anyway, so there's three different types we'll talk about, and the goal for this lesson is to identify them and be able to say how many solutions they have. So on the scale, you're a 3 if you can identify the type of system without graphing. You can do it without graphing, and I'll show you how, but you also need to be able to graph it. But for a 3, be able to identify without even graphing. Number 2, you can identify the type of system, but you can only use it using graphing. So if you graph it, you can be able to tell the difference. 1, you can identify the type of system, but only if the equations are in slope-intercept form, as in you have trouble changing them into slope-intercept form. And you're a 0 if you cannot identify the types of systems. Let's get started.
Alright, so there are three types of systems of equations, and each have their different kinds of properties. So first, an independent system has one solution. So that means in their graph, they will intersect only once. And the way that you can tell that a system is independent is they have different slopes. So here's an example equation, system of equations. So in this system right here, we have y equals 3x minus 2 and y equals negative 2x plus 3. So if we look here, we've got a slope of 3 in one equation and a slope of negative 2 in the other equation. So from right there, you can tell this is an independent system. Now, if we graph it, we'll be able to see that it has exactly one solution. So, first equation, negative 2 for the y-intercept, up 3 over 1. Second equation, up 3 for the y-intercept, down 2 over 1. Intersecting right there, we make our lines. And they intersect at exactly one point. Right here, which in this case happens to be the point 1, 1. So the answer to this would be x equals 1, y equals 1. These are the kinds of systems that you have been dealing with so far and are the ones you'll see most often. The next two are more special cases. A dependent system has infinitely many solutions. The reason for this is because a dependent system, actually, both equations are the same line. And the way that we can tell that it's a dependent solution is that both equations have the same slope, and same y-intercept. So here's the sample equation. So in this case, we have two equations, and remember to graph this one, we have to put it into slope-intercept form. So I'll rewrite the first one we had. Y equals 2x plus 1. The second one, we would have to add 2x to both sides of the equation, which would give us y equals 2x plus 1. So even though at the beginning they looked like different equations, they are now the same exact equation. And that's why they are a dependent system. Same slope, same y-intercept. So, same line. So if we went to graph it, 1 for the y-intercept, up 2 over 1. Second line, 1 for the y-intercept, up 2 over 1. Intersects at both of those points, and actually they intersect at every point, as long as I could draw. So, the lines intersect completely, and that's why it's a dependent system, because every time they intersect is every time, because they are a dependent system, they are the same exact line. In an inconsistent system, there is no solution. The reason for this is because the lines end up being parallel. They never intersect. And since the lines are parallel, that means that both equations have the same slope. But to make it different from the dependent system, they have a different y-intercept. So in an inconsistent system, they have the same slope but a different y-intercept. Here's a sample system. So we have y equals 2/3 x minus 4 and y equals 2/3 x minus 1. So if we go to graph those, for the first one, we go down 4 for the y-intercept and then go up 2 over 3. For the second one, go down 1 for the y-intercept and then up 2 over 3. Then we connect them to made lines. And we have two parallel lines. They go on forever and will never touch each other. They will never intersect. So that makes it so they have no solution. They will never intersect, so there's not a solution at all that will make the system true. So just remember, 3 types of systems: dependent, independent, inconsistent. The independent has one solution because they intersect at only one point, and that's where you'll get an actual x equals y equals. The dependent has infinitely many solutions because it's the same line, and the inconsistent system has no solutions because they are parallel lines and never intersect.
Alright, now time for the sponge activity. Identify the type of system and state how many solutions it has. So for each one, I want you to just what is the type of system, and then state how many solutions that system will have. If it has only one, you don't have to solve it. In the future, a lot of times you will have to solve it, but in this case, I'm just wanting you to state what's the type of system and how many solutions does it have. So, number 1, y equals 4x plus 3 and y equals 3x plus 4. Number 2, 2x plus 5, y equals 35, and y equals negative 2/5 x plus 35. Number 3, 2x plus y equals 4, and negative 2x minus y equals negative 4. And number 4, 2x plus 4y equals 8, and 3x plus 6y equals 12. That's it for the lesson. Once again, please make sure to take notes on the entire lesson, attempt this sponge, take a picture, submit it all to a backpack, make sure you state where you are in your rankings 3, 2, 1, 0, and have a good night.